Comprehensive Review, Assignment 4. The shape of the Earth is best described as an oblate spheroid. Remember that the poles are just squished down a little and the equator bulges ever so slightly. So we have an almost perfectly round Earth, but ever so slightly off. The direction of the Earth's rotation is counterclockwise when viewed from above the North Pole, or clockwise if viewed from directly above the equator with the pole at the top. This is why the clouds will go across the sky. The sun rises from in the east and sets in the west. Think about those different phenomena. The Earth rotates about its axis and revolves around the sun. It's important that you remember the difference between rotation and revolution. Rotation, it's like spinning a top, whereas revolve is moving around another object. So the moon revolves around the Earth. Remember though that the moon also rotates on its axis at the same rate that it revolves, and that's why we only ever see one side of the moon. The Earth is nearest the sun at perihelion. Peri means near, and that occurs on January 3rd. This is counterintuitive. Most people go, oh, it's really warm in July, so perihelion must be July 4th. But actually, July 4th would be a whole lot hotter, and right now you'd all be sweating a whole lot more if we were going toward perihelion. We're actually approaching aphelion. On the Earth's surface, the geographic grid consisting of intersecting parallels and meridians are identified by latitude and longitude, respectively. So latitude are going to be the parallel lines. We start with 0 for the equator and work all the way up to 90 north or 90 south. And then longitude are those intersecting meridians that they all meet up at the poles, which brings up the next question. All meridians converge at points located at the poles. Too easy. The single major problem all maps have in common is distortion. Distortion towards the poles, or toward the edge of the map. Think about a Mercator projection. That's when you have the cylinder around the Earth. The equator is really good, but as you move toward the poles, it gets distorted. If you have a planar projection, a sheet sitting on top of the North Pole, you're going to get really nice image of the North Pole, and then it's going to radiate outward. An iconic projection, like if you put the party hat on, that's going to give you the mid-latitude. So that'd be really good for the U.S., because we're the mid-latitude, but again, you'd get distortion down toward the equator. Remember that the best model of the Earth, or the best projection of the Earth, if you want to think about it that way, would be a globe. But that'd be very inconvenient to try and go hiking with. Alright, moving along. The planar projection is centered on the North or South Pole and contains meridians that are represented as circular lines. Basically, you have the pole at the center, and then you have concentric circles going around for each one of the latitude lines. Be sure to look at a picture online if you're confused about that. While the Mercator projection portrays the relative areas of landmasses on Earth's surface correctly, their shapes, however, become distorted near the poles. That's the key part to that question. Distorted near the poles. You got to be thinking Mercator projection. In the case of electromagnetic energy, hotter objects radiate more energy at shorter wavelengths than cooler objects. Remember, the gamma rays are going to be your shortest wavelength, highest energy, and radio waves are going to be your longest wavelength or lowest energy. And color comes back into that idea. We know that blue is going to be a hotter color in the case of stars, right? Blue stars are going to be hotter, they're going to be brighter. And then red is going to be a cooler color. Again, one of those counterintuitive ideas. You guys think because you go and turn on the blue handle for the cold water that blue is cold, but actually the color would be hot. The highest energy, shortest wavelength form of electromagnetic radiation emitted by the sun is gamma rays. Right? Gamma rays would be a big problem. Luckily, we have the ionosphere out there that's going to filter off and absorb a lot of that gamma radiation. Otherwise, we'd have some serious problems living here on Earth. Good. The Earth, maintaining a significantly cooler surface temperature than the sun, emits infrared radiation. So IR. Remember, that's the IR that is re-emitted and then trapped by the greenhouse gases, and that is going to cause our atmosphere to be heated and be habitable. If we lost those greenhouse gases, well then that IR would just radiate back out into space and the global temperature would be a lot cooler. Put too many greenhouse gases, then the temperature gets too hot. In the case of Venus, that has a very thick CO2 rich atmosphere. The equatorial region of the Earth receives the greatest amount of insolation. Twice a year, on either equinox, the equator is going to have 90 degrees of insolation. So if you think about it that way, they're always getting hit with a lot of insolation. That's why the equator's so nice to go on vacation at. Of the following gases, helium is not found in the atmosphere in measurable quantities. Nitrogen, you guys should remember, 78% of Earth's atmosphere, so that's the most abundant gas in Earth's atmosphere. Argon is the third most abundant, and carbon dioxide, over 400 parts per million. That's a measured quantity. Too easy. The chemical formula O3 represents that of ozone. Alright, let's rapid fire through a little astronomy, shall we? The largest circular storm in our solar system is on the surface of which planet? That would be Jupiter. That's a typo, sorry about that. And that's the Great Red Spot. That's that huge hurricane-like storm that's like twice the size of Earth. Pretty big. The rapidly moving stream of charged particles that is being driven away from the sun is known as the solar winds. So remember, solar flares are going to blast out charged particles, and that makes the solar wind. When those solar winds interact with Earth's magnetic field and the ionosphere, we see them as auroras. The largest volcano in our solar system is named Olympus Mons. This volcano is located on Mars. Olympus Mons on Mars. Too easy. And remember, that is a shield volcano. One Jupiter day is equal to just under 10 hours. It's like 9 hours and 56 minutes. We'll just call it 10 hours. The Hertzsprung-Russell diagram of stars directly compares luminosity and temperature. Some of the diagrams have color on the bottom. That's because, again, color is related to temperature. The Andromeda Galaxy is which type of galaxy? It is a spiral galaxy. We are also in the Milky Way galaxy, which is a spiral galaxy. About how many light years across is the Milky Way? It's 100,000 light years. 100,000 light years. Key point to remember here is that light years are the unit that we use to measure distance in space. Meters, inches, kilometers, miles, all of these would be way, way too small. Right? The smallest unit that you guys even want to be thinking about would be an astronomical unit, 150 million kilometers, the distance from the Earth to the Sun. And in the scale of space, that's actually really small. Only one planet in the solar system has a day which lasts longer than its year, and that of course would be Venus. I think we just went over that with the other activity sheets in class. The heliocentric model puts the sun at the center of the universe. That's Copernicus, that's support from people like Galileo and Kepler, and really upset the church. Really upset the church. So if you came out talking about the heliocentric model, you are going against the geocentric model, and you could be called a heretic. When the Earth is farthest from the Sun, what season is it in the northern hemisphere? Again, counterintuitive, that would be summer. We're furthest from the Sun during the summer, and thank goodness, because it's getting warm. Think about how much warmer it would be if we were getting closer to the Sun. A typical galaxy, such as our Milky Way galaxy, contains how many billions of stars? It's approximately 100 to 400 billion stars. That's a lot. Just throwing it out there. It's a lot of stars. A elliptical, spiral, and irregular are classifications of what type of astronomical system, and that would be a galaxy. Again, we are in the Milky Way galaxy, and that is a spiral galaxy. The visual aurora consists of luminous arches, rays, or bands in the night sky, usually confined to high latitudes and located in the ionosphere. Now, some of you are like, well, I put the thermosphere. The ionosphere exists in the thermosphere, so by default you're not wrong, but try to be a little more specific. Alright, happy studying.